one more video. Look, it takes us a long time, but this is a heavy thing. Okay, so it's good that we spend a lot of time on that. And if you're not happy or you're not sure, please let me know. Come and see me Wednesday, I think, is our clinic day. Yeah, let's not do WhatsApp, but just come and see me, okay, Wednesday, okay? Right, I've got another function. Now, look at this. Instead of doing f of x equals square root x all plus 1, sometime you've looked at function, you drew them like this, y equals square root x plus 1, okay? So, like I said, notation, we're going to see another notation now. Now, if we use that notation, y equals something with x instead of f of x, then the way we write the derivative of that function, we write it like this, dy divided by dx. I want to just explain to you where is that coming from. You know that average gradient, often we write it like this, delta y over delta x, the change in the y divided by change in x. Now, when we take the limit, when delta x is approaching 0, okay? Normally we call it h, right? We got the x and the x plus h. But if you think about it, what if the h, if that extra stuff that we added to the first coordinate, if that approaches 0, that means the difference between the two coordinates is 0. So limit h approaches 0 is the same as saying that the limit of delta x approaches 0. So the definition of dy to dx is simply that. Is when you take the delta x to approach 0, then we call it dy to dx. Okay? It's just another way of writing the derivative of y with respect to x. Okay? Right? Okay, so we're trying to find out the derivative of y at x equals 3. Now, if you don't mind here, I'm going to solve like I normally like. I will find you, first of all, what is dy to dx. Not at x equals 3, just the general derivative, and then I'll substitute x equals 3. Okay? So, according to the definition, it's the same thing. It's limit when h approaches 0, where we've got x plus h, f of x plus h minus f of x, okay? Or let's say y of x plus h, because we're working with y's now, minus y of x, it's all the same thing, okay? Y of a certain x is the same as f of x, divided by h. Okay, what is y of x plus h? I'm substituting x plus h here. So, not just here, everywhere there's an x, I'll write x plus h. So, it's the square root of x plus h plus 1 minus the square root of x plus 1 divided by h. Keep on forgetting, limit h approaches 0. Okay, but now we're stuck. Okay, we really are stuck because we've got square root minus square root. What am I going to do with that? Okay, I can't just do it like one big square root and put x plus h plus 1 minus x, but you can't do that. Okay, a square root of 5 minus square root of 2, it's not square root of 5 minus 2, of course not. And that's nonsense, you can't do that. Now, there was one question, I know Olivia asked me about that, but I don't know if the rest of you saw it in a couple lessons ago. And there was something like that, it was a limit question, it was a bunch of square roots there. Okay, so what you got to do when you've got these situations, you got to use the property that we can multiply everything at the top as long as we all multiply also at the bottom. Now, what we want to really, our aim, okay, is to get rid of that square root. I want to get rid of it. How would I get rid of it? Look at this. If I multiply by square root of x plus h plus 1 plus square root of x plus 1, if I multiply the numerator by that, then I've got a minus b times a plus b, right? A is that. Oh, you can't see it. A is this. B is those. And you know I'm getting a squared minus b squared. So I'm squaring the square root. And squaring the square root, you're basically evaporating that square root. So that is fantastic. But I've got to remember that if I multiply the numerator by this ugliness, I need to also multiply the denominator. That's the price we have to pay. Okay? Right, so how much do we get? Again, limit h approaches 0. Okay? That times that is going to be a squared minus b squared. What is a squared? A squared is a plus h plus 1. Not square, just x plus h plus 1. Because the square of the square root, it's simply what you have inside the square root, right? The square, let's say 5. The square of square root 5 is simply 5. Okay? They're inverse functions, the square and the square root. Okay? So it's a squared minus b squared. What is b squared? It's x plus 1. Okay? Divided by this nasty stuff. H times square root x plus h plus 1 plus square root x plus 1. Okay? So I didn't get rid of the nasty stuff. I just shoved it into the denominator. But trust me, it will work out. Okay. Now we write it again. Limit. Okay, x plus h plus 1 minus x minus 1. So I got rid of the x and the 1, right? So all I have is h. Aha! And you can see where it's going. I've got h in the numerator. The denominator, I have that h and the nasty stuff. Okay? And then what do? Rit. We get the red pen. Okay? Get the red pen, slash, h is gone. Okay? More importantly, well, it's not that I don't have h in the denominator. I do. I have an h there. But it's not h times something. So now we can substitute h equals 0. You'll see. Okay? So I'm going to get rid of that approaches 0 nonsense, and I'll just, okay, bring it on. Let's make h 0. Okay? Now, here's a mistake that a lot of my grade 9 and 8 obviously will do. If I cancel these h, what do I have now? Don't get confused, right? H divided by h, I still have 1. Okay, so h divided by h, I still have 1. Don't say I have 0. Okay? And then I'm going to substitute x plus h, okay, 0. So it's x plus 1. Okay? Plus x plus 1. So instead of h, putting h, I put a 0. Okay, so it's x plus 1. Now that's no problem. Yeah, I don't have 0, okay, I have a 0 denominator, but it evaporated. Okay, I just have a bunch of x's. I can rewrite it nicely, and I'll say that the derivative of y, dy to dx, we say dy to dx, not dy divided by dx, dy to dx is 1 over 2 square root x plus 1. Okay, right? If this is my y, okay, let me just highlight these two things for you. If this is my y, that's my function, that's the general derivative, dy to dx. Okay? You might know, I mean, look, we've done a lot of work. We're very tired to get to that result. But I will teach you, not too long from now, a way of doing it very, very, very quickly. But it is important to do it. This is what we call calculate derivative using the definition. Okay? Also in normal maths, you need to know how to calculate derivative using the definition. What definition? This is the definition. Okay? There is another technique to do it without the definition. Way easier, but we still need to know how to use the definition. Now we're not finished, right? We want to find the actual gradient at the specific point, x equals 3. So all we got to do now is substitute x equals 3 over here. And we're going to write it dy to dx at x equals 3. I can write it like this, for example. Okay? It's going to be 1 over 2 square root. 3 plus 1 is 4. We've got 1 over 4. Okay? So square root 4 is 2. 1 over 4. You just see? Yeah, we got the right answer. Okay. Right. Guys, do me a favor. Exercise 5-2. Do it all. And just do it all. It's not that many. Okay? It will take you a while. It will probably take you an hour maybe. But just do it all. This is one of these things. It's like it's a moment where it's an important moment to understand what the derivative and calculating it using the definition. It's both not easy and it's really important for the understanding of what does derivative mean. Okay? And especially with these questions with the limit. I know it's difficult, like hang on, are you saying h is 0 or is it not 0? You decide, okay? Initially, we just keep it as an h until we get rid of it from the denominator so it's not in a dangerous position. And then bam, we put it as 0. Okay? Enjoy and let me know if you struggle and we'll work on it together.